The goal of this project is to design a first-order high-pass filter with certain cutoff frequency and passband gain. Translate the problem statement to design specifications. The cutoff frequency need to be 40 Hz and the passband gain is 1. We choose to use a common first-order active high-pass filter as a prototype and 0.0047 microfarad for the input capacitor. The cutoff frequency of this high-pass filter is 1 over 2 pi Ri Ci if Ci is known and the desired cutoff frequency is 40 Hz. We may solve for the only unknown. The input resistance is equal to 847 kilo-ohm. When build the circuit, we use the closest value, 820 kilo-ohm. That's our input resistance. With this design, we recalculate the cutoff frequency. It's 41 Hz theoretically. Second, we know the passband gain of this circuit is determined by the ratio of Rf over Ri. The desired passband gain is 1, which means the feedback resistance also need to be 820 kilo-ohm. Look at the real circuit. The input capacitor, which is in series with the input resistor. Here's the feedback resistor Rf. When test the circuit, the transfer function of this active high-pass filter is shown here. This is a function of frequency. At low frequency, it approaches 0, so the signal attenuates. At cutoff frequency, omega is equal to omega c. This becomes negative Rf over Ri times, now omega becomes omega c, so j omega c times Ri Ci over 1 plus j omega c Ri Ci. The group of Ri Ci is equivalent to 1 over 2 pi Fc based on how the cutoff frequency is defined. On the other hand, the angular frequency omega c is related to the cutoff frequency by 2 pi, so those two are crossed out, and the transfer function becomes negative 1 times j over 1 plus j. Calculate the magnitude of this complex number, we get 0.707, which means the output is 70% of the original input magnitude. When the frequency is higher than the cutoff frequency, the attenuation rapidly decreases to nothing, and the transfer function is getting closer to 1. That's why this circuit is called a high-pass filter. In the next, I will show the input and output signals at a few different frequencies. This is a very low frequency, 1 Hz. Check out the magnitude of the signals. The output is really low. The second case is a little higher, 10 Hz. The magnitude of the output increased. This is our theoretical cutoff frequency, 41 Hz. Result shows at the cutoff frequency, the magnitude of the output is close to 70% of the input. We may also make use of the sweep function of the function generator to check out the frequency response of the filter. Zoom in, we could see the increasement of the output while the frequency is increased. To summarize, at low frequency, the magnitude of the output signal is low. At the cutoff frequency, it's about 70%. At frequencies above the cutoff frequency, signals pass with ease. In conclusion, the first-order high-pass filter we designed in this project is an active high-pass filter with a cutoff frequency of 40 Hz and a passband gain of 1.